Welcome to today's video, where we're going to take a closer look at tilt sensors and explore how they function. Tilt sensors are fascinating devices used in a wide range of applications, from simple gadgets to advanced robotics. And today, we'll be putting one to the test. We will walk through how it works, demonstrate its responsiveness, and see some practical examples of where and how it can be used. So without waiting, let's begin. The SW520D, also known as tilt sensor or tilt switch, is a simple, cost-effective, and reliable device used to detect orientation or inclination. This sensor has 3 pins, which are V, C, C, G, and D, and the digital output. This type of sensor is equipped with a built-in potentiometer, allowing us to easily adjust the sensitivity or set the threshold angle for the tilt sensor. The SW520D contains a conductive metal ball inside a cylindrical housing. When the sensor is tilted beyond a certain angle, the ball rolls to one end, closing the circuit and allowing current to flow. Now let's dive into building a simple circuit to see the tilt sensor in action. All we need are the sensor, a few jumper wires, a power source, an LED, and a breadboard to get started. Now we can begin by connecting the jumper wires to the sensor first. Next, connect the negative side of the power source to the shorter leg of the LED. Then, connect the VCC pin of the sensor to the positive side of the power source and the GND pin to the negative side. This will turn the LEDs on the sensor on. For the final step, connect the digital output pin of the sensor to the longer leg of the LED. This will complete the circuit, allowing the tilt sensor to act as a switch between the power source and the LED. As you can see, when I tilt the sensor to one side, the LED turns on, and when I move it back to its original position, the LED turns off. For the next step, we can incorporate a microcontroller to take this prototype to the next level. All we need to do is connect a buzzer and an LED to demonstrate when the tilt switch is closed. Then, we'll connect the sensor to the microcontroller to read its output signals and enhance the functionality. Next, we'll write the code to receive the signals from the sensor and program the microcontroller to decide what actions to take based on those signals. First, we'll define the variables that we're going to use. We'll use pin 12 of the Arduino to receive the digital output signal from the sensor, and pin 4 to control the LED and the buzzer. Additionally, we'll create another variable to store the value of the digital output read from the sensor. In the setup method, we will set the pin 12 as input and pin 4 as output. Now it's time to read the value of the sensor by using the method digital read and storing it in the variable we created before. Now, by using an if statement, we'll check if the value received from the sensor is high. If it is, it means the tilt switch is activated and will trigger an alarm by turning both the LED and the buzzer on. If no value is received or the value is low, we'll turn both the LED and the buzzer off. For the final step, we'll add a small delay at the end of the program to ensure stability and prevent rapid toggling. Once that's done, we can upload the code and see our results in action. As you can see, by changing the angle of the sensor, the alarm turns on, demonstrating how the tilt sensor effectively triggers the system. This is a great example of how this sensor can be used in security systems to detect even the slightest movements and trigger an alarm in response. Please leave a comment below to let me know which sensor you'd like to see in the next videos. And don't forget to like and subscribe for more exciting projects and tutorials.